Good day to you all, wherever you are. Welcome to the British Interplanetary Society's 10th live-streamed Q&A session. It's great to hear that vaccines have been developed and that there is at last light at the end of the COVID-19 tunnel. But I think we may have to carry on as we are until Easter of next year. We're certainly planning our big Beyond the Moon symposium on 12th of April as a virtual conference, but we're hoping to run our Reinventing Space conference on the 28th to 30th of June as a full-blown conference in the QE2 Conference Centre in Westminster. For those who don't know me, I'm Alistair Scott, a past president of the Society, but now as chair of the events committee, I try to keep all our events and activities going. Last month, we heard all about the development of Dawn Aerospace's space planes, and today we're looking again at a fairly young organisation, deorbit, which seems to be living up to the motto of the British Interplanetary Society, from imagination to reality. The crowdcast system seemed to work well for us last time. Let's hope we have a trouble-free session tonight. Please use the question system to ask your questions, and you can also vote for those questions you want to hear asked. I'll try to ask them in the right order this time. I hope you've all had a chance to watch Chris Brunskill's excellent talk on deorbit's logistics solutions in space. I'm pleased to have Chris with us tonight to answer all your questions. I don't want to take up any more of your time by introducing him, but will say that I have known him for well over 10 years, when he was still at Surrey University and coordinating all the events for UK SEDS. I'm pleased to say he was recognised and rewarded for all his hard work in 2011 by being awarded the Sir Arthur Clarke Student Achievement Award. And it's great to see what he has been up to in the intervening years. I'll now hand over to Chris for him to say a few words while I search out the questions. Over to you, Chris.
Thanks, Alistair, and thank you very much for inviting me to come and talk about what I'm up to at deorbit and also for this Q&A session tonight. I'm really looking forward to answering some of these questions. So just sort of very brief history of what I've done in the past. And as Alistair said, I studied at the University of Surrey on the electronics course, but specialising in small satellites. That was back when SSTL was still on campus and part of the university. So that was a very early exposure to what small satellites could do and how we go about building them. And it's funny to think where they fit into the bigger picture. Back then, it wasn't so big. I stayed on at Surrey to do a PhD, actually veering into space robotics, but came back into looking at novel applications and mission concepts for small satellites. And just to sort of condense the last 5 or 6 years into a nutshell, if I'd known back when I was at Surrey that small satellites would be so relevant today and that there were so many opportunities to create careers around them across the world, I would not have believed you. So the advancement that we have seen in such a short period of time and the credibility and capability is incredible, and that's what really motivates me, and that's why I do what I do and why I'm happy to talk about it.
Right, well, we've got some interesting questions for you here and some more coming in, and please keep them coming in because we've got half a dozen to go. No, a dozen to go now. Right, the very first question then is from Les Shoulder, who I'm told is holed up in a hotspot, a COVID hotspot on the borders of London and Essex. He says, regarding space debris removal, does your company have a favourite system that is developing, or will you just operate as Spacebus for other companies' offerings?
It's a great question. The short answer is we don't have a preferred system at the moment, but I think the reason for that is because there isn't really a preferred system at the moment, and the technology question around debris mitigation and orbit servicing is a really interesting one, and there's a number of companies, some quite prominent, that are working on this. So our position is to look at how we can collaborate as much as possible, look at where the technology direction is going, and then work with the right partners to find those solutions. That's not to say that we wouldn't develop our own technology, and indeed we do have our own internal programs looking at the different approaches that might work. But equally, we're not looking to necessarily reinvent the wheel where it's not required. There's also a commercial aspect to this. We have always strived to be a commercially sustainable business, and I think this came across in the talk. We obviously do work with the various space agencies, ESA and the UK Space Agency and the Italian Space Agency and so forth. But the core business is a commercial one and sustainable in that sense. So when it comes to the debris question, as I say, we're still in that earlier phase where the market's still emergent, still sort of deciding what it's going to look like, and taking a very broad approach to that. So no preferred solution, but we're certainly focused on that area in the future.
Great, thank you. Right, actually, surprise, surprise, the next question is actually from me. Yeah, your iron satellite transporter is a great idea and appears to be able to do some amazing things in deploying and distributing small satellite constellations. But can it only be launched on a launch vehicle that is only going to LEO and at a specific orbit inclination? Can it deploy satellites in other inclined orbits at the same time?
Yeah, so quite a lot to unpack in that question. The good idea bit is somewhat linked to the previous question, in that it started off as a good idea a few years ago. Again, talking about sort of the market for space transportation services, that at that time, even then, was still somewhat undefined in terms of how big it is and whether or not it'd be sustainable. But we saw the opportunity to build a solution that met those needs. And the growth over the last couple of years in demand for space transportation services has just been enormous. And we're seeing increasing interest in this, that there are other organizations and businesses around the world that are looking at similar solutions. But we really sort of got there first, if you like, with the idea. And as a result, we're quite far ahead, having already demonstrated that service earlier this year. And as you're aware from the presentation, a whole host of subsequent missions planned for the future. So with that, what we're able to do is iterate the technology really, really quickly. And this is very new space, very agile approach. We're much more focused on demonstrating the art of the possible rather than spending years and years and huge amounts of money studying ideas and coming up with the one single one that is then the only one that we can pursue. And we see that between ION Mark 1 and ION Mark 2. If you consider they're only going to be launched a few months apart, the evolution between those two is enormous. So we really focus on continually evolving and developing the capabilities. So in terms of where we can go with ION, currently from a market-driven perspective, LEO is the place to be for obvious reasons. So the principal design drivers are around creating a capability that can serve the LEO market. In terms of where in LEO we can go, it's anywhere. I mean, the whole point is that we can change inclination, we can change the altitude, we can change the LTAN if needs be as well. And in addition to that, other services like the true anomaly phasing and so on. Now, there's a trade-off, of course, with all of those options, and anybody that knows a little bit about orbital dynamics will understand the energy demands change quite vastly depending on what it is you'd like to do. But in principle, at the end of the day, the fundamental solution is a propulsion system that enables you to change the nature of your orbit, and that's what we offer, and that's what we're able to provide. We also do use some of the natural environmental conditions. So the J2 effect, for example, due to the ablateness of the Earth, allows us to do things like LTAN shifts for free. Now, obviously, there's a time penalty if you do that completely passively. But again, we've got the option to combine that perhaps with a propulsive solution as well, depending on what the particular mission is carrying, who the customers are, where they need to be, and so forth. So we're very flexible when it comes to the LEO solution. And again, what we're trying to solve here, and this is sort of what I was trying to say before, we're we're really not trying to pick a sort of an adversary or a competitor and do something similar but better, or similar but an alternative. We're really looking at where we fit in the gaps or help bring together gaps in the supply chain for space missions and solutions. And in my previous role, I was responsible for understanding the UK space market in the upstream area, particularly in new space. And really the problem that we had, particularly in the UK, is that while we've got all of these constituent parts, launch and manufacturing and operation, it was very fragmented. So if you wanted to create a mission as a startup or perhaps a business pivoting, the overhead just in understanding how to work with that market was extremely difficult still. And there's still work to do there in terms of helping federate all of those solutions, and that's really where we try to fit in with the orbit, is to break down the high sort of, or the steep learning curve to speak that language. We can be a single point of entry, but then we don't try and own the complete solution. We then go out and work with the right partners to make the sort of mission solution as effective as possible. Beyond LEO, just to sort of take your question to sort of the next stage, yes, I mean, absolutely. Again, we are looking at mission concepts which do take us beyond LEO. There's not much I can say about those at this point, mostly because I've not anything to do with that particular part of the business. But certainly we do see the opportunity, obviously for GEO, there's a market there in the existing satellites up there. But beyond GEO as well, we see increasing interest in things like the lunar environment, the various programs, the international and institutional programs, looking at the sort of presence around the moon, and beyond as well. So it's not necessarily the sort of the prime focus, but it is definitely something that we keep in mind when we're always looking at what the capability of our technology is. When we decide to invest or develop future technologies, it's looking 2 or 3 steps in advance and making sure that we're always pushing towards the more visionary capability by doing the real stuff today.
Fascinating. Quite a look to the future. I suppose what I was really getting at was, if you need to put several different satellites into several different inclinations or inclined orbits, you'd have to vary the amount of fuel you had on board.
Yes, absolutely. And again, this is part of the service, if you like, that we can offer, which is looking at what we can provide with the ION missions that are available, but also what launch opportunities exist. ION is compatible with all of the typical launch providers. We're doing a lot of work in the UK with a micro launch community that's starting to gain traction now, to ensure that we have an offering through that option as well. And again, what that means is that you don't need, if you're an owner or an operator of a spacecraft, and all you really need to care about is that it's generating revenue, that it's making your business wheels turn, and that you're effective as a solution. You shouldn't have to waste time trying to work out if you use rocket A or rocket B on this month. We can work all of that together and come up with a solution that meets those particular demands of your business. And inclination is an obvious one, right? Because there's such a huge demand in the energy to change from one to the other. We could come up with a combined solution quite conceivably, using multiple launches, but perhaps within a few weeks or a few months of one another, and have the whole constellation deployed and operational very shortly thereafter. Again, rather than looking at maybe making that a much longer duration solution if you were to do it by yourself.
Well, thank you. Yes, quite a question, quite an answer. Right, I've got another one. Actually, it's from me again in Bedford, and this is something you might want to listen or ask yourself about. Does your ion transporter have a deorbiting system on board itself?
So yes, is the short answer. Again, one of the core capabilities of ION is it has this propulsion system on board, and clearly as part of the operational concept, we can build in the end of life part of that mission as well, use the same system and reduce the orbit, particularly in LEO, where it's easier to reduce the altitude to a point where the orbit will naturally decay much more quite quickly, much more quickly than would have done otherwise. Yes, I think I was going to add something else. My mind's lost the thread, but yes, the answer to your question.
Right. Well, we'll move on to the next one, and this is for Anne, from Ange and Nigel, hiding somewhere in London, and they ask, or Nigel would like to know, if there's any involvement from the University of Surrey.
Yeah. So again, great question, and I'm pleased to say, as an alum, that yes, we do have some relationships with Surrey. Surrey's really interesting because they are the hosts of the Fairspace Hub, which is a space robotics R&D group, if you like, but they represent the national interest. So there's various universities and various industrial representatives that form that sort of working group, if you like. And then they have a number of postdoc projects, PhD projects, and industrial collaborations as well. We've been looking at various, back to your first question, actually, various methods for deorbiting and servicing with them. And again, you know, at this stage, and really in many ways, the purpose of Fairspace was to understand what these technologies, you know, what the right technologies are, and what the sort of promising directions to take that R&D and we're going to be. So I can't give you a sort of straightforward, this is X that we have done with them, but we're working to understand where we can create these more tangible projects in the future around the robotic element of on-orbit logistics.
Thank you. Now, the next one is from Les Shoulder again, and he says, can you say who will launch the Iron Mark II satellite, where from, and on what rocket system?
Yes, I believe it's public. We're going up on Falcon 9, and that'll be from Florida, I guess the Cape. But I sometimes mix up the exact launch location, but yes, it'll be on Falcon 9 at the end of this year.
Right, that's the December launch, and it's again an Iron 1. Is it an Origin 2 or something?
So this is, I think it's called, so we have an internal name and an external name. I'm trying to remember the external name now.
Well, not to worry, it's in December sometime.
Yes, but no, December is the target launch month for that particular launch, and it's a Mark II. So just to sort of clarify that the Mark I really, in many ways, was a proof of concept in showing that we could essentially take the CubeSat deployers, put an avionics system, a propulsion system on the base of that, and then continue to do stuff after deployment. So that's really what we validated with ION Mark I in the last couple of months. But as I say, Mark II really is a huge evolution of that. And again, if you look at the presentation, some of the graphics there, you see the difference in the approach. A lot of the core avionics are common with ION, but it's being uprated in terms of certainly its scale and other areas of its capability as well.
Now, Peter Robinson's put in a comment quickly. He says, is it a Starlink ride share?
Is it a Starlink ride share? I don't think so. I mean, that, again, you'll probably look it up. But I believe it's a polar orbit, so it won't be a Starlink.
We'll have to read all about it in spaceflight after it's launched. The problem with spaceflight is the digest is now so long with every Starlink launch with 60 of the things, and they're all listed individually. Yes. So it makes
Starlink Planet a few years ago sort of really sort of fudged the numbers in some ways. But I mean, it's an interesting comment because, or just to sort of continue that train of thought. I mean, again, for a long time, my job was to sort of show that there was value and traction in using small satellites and CubeSats in particular, but small satellites in general as a commercially viable, solution. And we used to, well, I say we, in my former role, we would track launches and sort of the mission types and what these things were being used for. And then Planet came along, and again, we sort of then had to take those data sets out and say, that's with Planet and that's without Planet. And now again, we're seeing the same with Starlink, where you sort of have to say, that's with Starlink, that's without Starlink. And And as a holistic picture, it's extremely valid, but you have to sort of take it into context.
Right. Well, things are moving fairly quickly here because we've got people voting up some of the questions. And so we've got one from Mike Lawford next, who says, who do you see as your main competitors across the various services you provide?
So it's a good question. Obviously, we do have competitors, but I'm reluctant to sort of call out any particular names, because again, our strategy really isn't to, as I said earlier, to sort of find someone and say, right, we can do that better and try and compete with them. Our approach has really been to look at how we can find ways of working with other companies in partnership and sort of help fill those gaps. So for example, ION as a platform, it can obviously fly the payload CubeSats. It can also host payloads. We also have a ground segment solution as well that can be integrated into that mission solution. So we use that for mission operations, but we're also developing capabilities to use it as a data dissemination and processing platform as well. So at the end of the day, what we're trying to do is look at ways in which we can provide the portfolio of capabilities rather than trying to like I say, pick one particular niche and sort of own it completely. It's the fact that we're trying to, as you said at the start, trying to sort of follow this much more vision-driven approach means that getting sort of stuck competing with, at a low level at this stage is not contingent to being successful or sustainable in the future. So, as I say, I'm not trying to avoid the question, and again, it wouldn't take too much to sort of pick out very specific people, but I don't think it's necessarily as straightforward as saying, A does this and you do something similar, therefore you're competing. It's just not the way that particular part of the industry works at the moment.
Hopefully you move on to where there isn't any competition every other day.
Yes.
Right. I've got one here from Robert Law, who says, are you working with space companies in Scotland?
Yes, absolutely. So as I say, we're very proactive in trying to establish a position with the UK launch community that's starting to emerge. So obviously there's a huge amount of activity in Scotland around that. And as we see it, the reason why deorbit is in the UK is because of the market position that provides us with. Not to mention, of course, all of the expertise and skills that we have here in the UK as well. But we see this as an opportunity for us to open the UK to the global market for launch services, but also to provide this sort of holistic UK-based solution as well. So yes, absolutely, we're working with companies in Scotland. In fact, I can tell you we've just announced we're working with Clyde Space on a new project called Expansion, and that's really interesting because that's looking at automating a huge number of the processes in delivering mission solutions. So that's a really interesting concept because that allows us to sort of take away those barriers to creating mission solutions and literally at the press of the button being able to share information up and down the supply chain. But equally, we're working with other companies and around the country. I mentioned Cornwall, so that obviously is where Virgin is based. Again, another launch provider, somebody else we're very keen to establish a relationship with through our launch service provision.
Well, thank you. I think my education was all done in Scotland, so I can't really. Right, enough of that. Let's move on to the next one then. To what extent do you see deorbiting playing a role in future servicing that involves replacing hardware on customer satellites? This is from William Easdown. You'll know him as an ex-chair of the of UK SEDS.
So, hi, great to see another alum. I think there's possibly two bits of that question. One is sort of deorbiting end of life equipment, and then there's also the servicing and repairing element to it. And I guess, in some ways those are linked. If you're repairing or replacing a faulty component, you need to do something with it at the end. As I say, the future of where we're going, or the next step in the future of where we're going, is absolutely focused around on-orbit servicing and debris removal as part of that. Again, in LEO, the obvious way of disposing of end-of-life equipment is to deorbit it, and the platform that we're developing. This comes back to that whole sort of strategy of what we build today helps us do what we're going to do tomorrow. These aren't built in isolation. So the platform that we've developed, that we currently call ION, is a very compact, capable, high performance and high reliability small satellite bus. So from that, if you take the dispensers off the upper deck, as we call it, and put other equipment on board, which could be a robotic system that allows for servicing or for docking or mechanical integration of some kind with an end-of-life spacecraft, then we're able then to use that platform in the same way as we do for our transportation solutions. However, in this case, instead of moving the orbit to somewhere where you'd want to operate, it's now moving to an orbit where it would end its life more rapidly. And again, there's a trade-off of how low you go and which orbit that happens to be, and all the questions around where it's likely to re-enter and what you're re-entering, and so on and so forth. In terms of the on-orbit servicing for repairs, if you like, or component replacement, I have a personal view of where we're going with that, and it sort of somewhat came out, I think, in the presentation, that's probably the next or the first step that we'll see towards proper full-on in-orbit manufacturing, and essentially sending up kits of parts rather than completely assembled spacecraft on launch vehicles. And we start to see some ideas. James Webb Telescope is an obvious example of where you've got, it's all interlinked, but essentially it's assembling itself on orbit with the mirror and then the heat shields. So take that to its sort of limit condition, and what you end up with is a kit of parts, and then you have your servicing capability on orbit to then take those components and assemble it into a functional platform. So that's just another step. It's another way of using that same solution you might have for space debris. Now, what's interesting is there's much more likely, I would argue, it's much more likely that you're going to have a space debris, or maybe space debris is the wrong way to think about it, but a constellation end-of-life servicing solution is much more likely to have a business case around it in the future, more soon in the future, than building kits of parts of satellites. So while that will ultimately get there, it'll be the servicing bit that we get to first. So again, it's what can we use with the technology today to get there, and then what can we use the technology we develop for that to get to the next step, which is building these spacecraft on orbit. And then by the time we've developed those solutions, the market may be ready to take advantage of those services that can be provided for the assembly of spacecraft on orbit.
Interesting. I suppose once you get to GEO, there's more likelihood of you being able to swap components than doing it on LEO. Satellites are too small and difficult to handle.
Well, no, I don't know if that's necessarily the case. I mean, the GEO platforms are probably as highly integrated, even though on a larger scale, as a small satellite. And actually, there's a cost-benefit analysis. Would you even bother trying to repair a $100,000 or even £1 million satellite? That being said, there are very high-value LEO spacecraft that would be worthwhile, and larger space. Envisat would be an obvious example, right? The huge elephant in the room, and also in low Earth orbit. Obviously there are environmental challenges that come from both of those regions, and the spacecraft themselves present challenges. What's really interesting is what we're seeing with some of the on-orbit servicing solutions in GEO. I think that's actually quite a major milestone in terms of the life extension missions. Now, whether or not there's a business case at the moment to sustain that, perhaps is something that can be called into question. But certainly, as an engineering solution, we're there, and that again is sort of the real proof of concept or proof of principle for the first step towards doing more comprehensive things. And I glossed over my point. The point was utilizing what's already there in the docking ring, and the I think the thruster bell as well was used for that particular mission, to provide a life extension service. The future of satellite design, particularly for the higher value assets, will start to benefit from designing in the ability to refuel or have components upgraded or replaced when they fail and so forth.
Right, sorry, we've got a lot of comments coming in.
I'm here. On, so please do stop me if I...
No, that's fine. I think we've got plenty of time. Yes, hello from Dundee, hello from the west coast of USA. So we are covering the world. All I need is Australia and New Zealand, and we've got the whole lot covered. Someone's lost my image. Right, he can see me. We're all right. Right, let's get on. Oh, look, I've hogged the next question too. And this is actually going right back to the beginning of your talk. I was slightly unclear on this, and it says, or I say, at the beginning of your talk, you mentioned that one of your first deorbiting devices was an arming and triggering device. I assume it had to be incorporated into the satellite while it was being built. But if at end of life the satellite is out of control, what does it trigger to make the satellite deorbit? Because the device has no propulsion or guidance system.
Yeah, so firstly, this was long before I joined the company, so I'm not going to pretend that I can talk to into any great depth around the particular solution that was developed. But what I can talk about is again, what we're trying to prove through developing that technology, and it was really to show that we can create this high reliability solution that is independent of the platform. And yes, if we were to develop a whole mission solution, a whole service proposition around that, then all of the points you've raised would have to be taken into consideration. But what we were able to show with that is that as a business, but also from a technological capability position, those kinds of solutions can be built as essentially closed systems that are independent of the main satellite bus. And from that, you can then start to look at how you offer those services for end-of-life solutions. What I will say is really, again, we were way ahead of the market with that.
More as a proof of concept idea.
Exactly, and while it wasn't necessarily the right time to sell that as a solution off the shelf,
right,
all of that work has fed into Ion.
Yeah.
Ion, if you like, is the sort of spiritual successor to that, in the fact that all of that expertise and experience went into the design process for Ion.
Right. Yeah. Oh, look, I've got another one here. I ought not to ask so many of my own questions. Oh, something's just shot to the top. Let's see if I can get that one. Yeah, there's one from Alan Marlowe here. He's, hi, Chris, is there a fixed cost for a single unit launch, and what is it? For multiple unit launches, is it simply a multiple of the single cost, or is there a discount for multi-unit launches?
So I can give you the sort of cheeky answer of I'm not on the sales team, so I couldn't possibly comment on what we charge for our solutions. I mean, I think the basic approach is, yes, it's done on a per U basis, and there are a variety of factors that contribute to that cost. So it's not as straightforward as saying, you know, it's X $1,000 per kilo or whatever. And again, that's because we're not. It's, as an engineer, it almost pains me to say this, but it's all about the commercial factors in this. We're not looking to be a race to get into a race to the bottom in terms of pricing. We're looking at where we can add value in the services, and then offering those as part of the solution that we present to the market. So it depends is really the answer. Do you want to go to a particular orbit? Do you need to be deployed at a particular time? Is there a particular country that you can or cannot be launched from? So, you know, all of that will be factored in. And yes, obviously, if you're going to be a long-term or a particularly large customer, then you know, we're very driven by what our customer needs are and how we can best service those.
We like to stay in all the best hotels.
Something like that.
Yeah. Right. It's interesting. Oh, this one is from me again. Whoops. It's interesting to hear that you had to develop your own ground control system. During a mission, are you able to control or send commands to your device, your transporter, your deorbiter or derazer 24/7 and at any point in its orbit?
Yes. Again, that's a short answer. So the sort of story of the mission control system is an interesting one. Interesting, but also not surprising in that it was a sort of a new space problem, right? We needed a mission control solution. We went to some of the usual suspects, and they came back with quotes that were more than the company was worth for an operation solution. So it was certainly cheaper and easier in many ways for us to develop our own solution in-house, and that's what we've ended up using, and that's very mature now. And it's always on a development sort of process, but we have a core capability that's extremely versatile and very high reliability. Again, the sort of it's the traditional situation here where we've developed something that's useful for us, and actually it turns out that's probably useful for other people as well. So now we're looking again at this option of building that out to meet more of our wider customer needs as a platform to either provide operations as a service or to sort of assist our customers and partners with operating their own platforms as well.
Right. And now we've got one here from Peter Robinson. And he says, you mentioned payload processing in Cornwall. Will you be launching from there as well, or from elsewhere in the UK, meaning Scotland?
So again, I think I mentioned or covered this earlier, but one of the main reasons we're in the UK is because of the huge amount of investment in the UK space sector that we've seen over the last 10 years or so in particular. And Launch UK is one of the sort of bigger flagships that we've seen from that. So clearly there's an opportunity for deorbit to build relationships with all of the launch providers. And as I said, also the UK has a fairly unique position in terms of access to other markets around the world as well. So we really see this as the opportunity for us to provide a logistics, a sort of terrestrial logistics solution to again make it easier for, as I say, either global customers to launch through the UK and through the deorbit services, and indeed for the current manufacturing base of spacecraft in the UK to take advantage of what's also being developed from a launch perspective as well. So I'm not avoiding the answer to the question there, but as I say, we will not say no to anyone at this stage. The more launch solutions that we can offer, the better our service will be.
So the answer basically is yes.
Yes, it's TBD, but yes.
Right. I'm glad we had a full answer though. Right, thank you for that one. Now, this one's from Ange and Nigel again. What permissions do you need to launch the vehicles that you are allowed to launch? Allowed to launch anything, or are there restrictions on the types of payload? And are your activities monitored by government agencies, or is it a free-for-all basically?
Okay, so again, a lot to unpack in that particular question. I guess of course, the first answer is, or the immediate answer is, we follow all the regulatory requirements that are bestowed upon us by the launching nation and the licensed nation. In terms of from a sort of from what we offer perspective, in principle, there's not an awful lot that we couldn't accommodate, and that's kind of again our approach. So for example, again, propulsion, if for whatever reason you needed propulsion on top of the propulsion you get from ION on your payload CubeSat or smallsat, for example, you wouldn't be able to launch that or deploy that from the ISS because or at least not without a huge headache of validation to ensure that the astronaut lives are safe. So we can work to find solutions for that as well and offer an alternative means to getting to orbit. as I say, in terms of permissions, we're subject to the same licensing conditions as everybody else, and we go through the same process. We're very keen to be an active part of that conversation, actually, partly through the fact we're looking to provide these end-to-end sort of missions launch service solutions, but also to make sure that particularly in the UK, the environment is favourable for the commercial community, and there's a number of consultations that have recently been published by the government and the UK Space Agency in particular, as they've been implementing some of the secondary legislation around the Space Industry Act, I think it's called now, lose track, and ensuring that our needs are reflected in the way that those regulations are put in place. I could do a whole extra presentation on the pros and cons of the current regulatory environment in the UK. I think generally it's a net positive. The current approach seems to rely a little bit on ambiguity as in place of an explicit solution, which again has pros and cons. But what that does mean is, again, very UK centric here, that it's a very predictable environment that you then, despite it being somewhat ambiguous, it's a lot more predictable than other regions as well. And there's the risk of the regulatory environment changing fundamentally is quite low, because we already have quite a comprehensive position set out. And a lot of what we're putting in place, what the government is putting in place now, is trying to capture that in a more predictable way. So I mean, there's still some way to go, but in many ways we're a long way ahead of many other countries, even the US in some ways.
Yeah, I think government support is leading the way on that one, and I think they will obviously try and make the regulations live up to that.
Yes. Yeah, I could just to sort of maybe dwell on that point briefly. There's an interesting sort of perspective there, because traditionally the space industry has been very heavily dependent on government funding. The history of it being a government kind of activity, a governmental activity to work in space, and clearly more recently that's not the case at all. We've got this huge sort of drive of commercially focused activities, and purely commercially focused activities. But that doesn't mean that government and governments don't still have a role to play in ensuring that the use and access to space is meaningful in the context of where those activities are happening. And again, the fact that the UK, for better or worse, has had such a huge focus on stimulating the UK space sector it's great. The fact that we have that level of dialogue is fantastic. As frustrating as it is at times, in other countries it simply doesn't exist, and again, that's a huge commercial risk. So overall, I think we're in a net positive position.
Nice to hear. Wasn't like that in my day, but never mind. It's good to hear it now. Right, we'll move on to the next one. This one's come up. Oh, Ange and Nigel again. Do you see any benefit of partnering with the big players, SpaceX, Blue Origin, or Boeing, or not? If not, why not?
I mean, I think as with any small business working with a prime, there are inherent risks, a large prime, in various aspects, like sort of protection of IP and the costs of working with those kinds of program management processes. But equally, we offer something that large primes can't do, and that's the agility and the responsiveness and the appetite for risk that simply doesn't exist in those large corporate environments. So, again, I think we can be very complementary to the way those businesses work. We can add a lot of value to reaching new goals, and we absolutely do work with large businesses and primes on a regular basis.
Yeah, and you'll be going up on Falcon 9, so we'll see how that goes.
Absolutely, yes.
Yeah. Right. Next one here is let's look. Oh, it's been voted up again. It's from William Eastdown again. And it says, or he says, regarding your space debris work, I noted that you're looking into debris tracking as well as removal. Will that be done using the Iron vehicle itself or a constellation of CubeSats deployed by Iron?
So great question, and actually this is something that we've managed to build an awful lot of traction on in the UK since we sort of really got going. So the UK arm, by the way, it was only created, I think, middle of last year or thereabouts, and I joined in March, and I was employee number 2 in the UK, but we've quickly scaled up, and I think we'll have about 10 people by the start of next year. So we've managed to get going quite quickly, and one of the reasons for that is, as I was saying, from sort of the government kind of angle here, there's a huge interest in government in space situational awareness, debris tracking, from the safety aspect, but also from the responsible use of space perspective as well. So, the UKSA put a call for proposals out over the summer for a relatively small amount of cash in the grand scheme of things, and that allowed us to really think about what we could do quickly and with what we had. And the solution we came up with was to use ION Mark 1 as an asset that we have on orbit and have access to experiment with the types of services that we would be able to provide from that platform. One of the main objectives is to see what the extent of that capability is using the sensors that exist on board already. So we have cameras and things on there, can we use those now to take images of the star field, and then can we use those images to detect other objects, and how far away can we detect them, under what illumination conditions can we detect them, and so on. So this is taking something that wasn't designed for this purpose whatsoever, and looking at how we can provide or add value using that capability. Now, the other part of this project is then to look at what happens next, and again, we're probably not going to build our own constellation of CubeSats. We're probably not going to build a dedicated SST ION. I mean, never say never, but that would need a very strong business case in the future to do so. What we are doing is launching lots and lots of ION carriers, and what we can do is look at how we can further use the sensors on board those platforms, perhaps augment them, and we're very interested in using RF tracking techniques as well. So if you've got an SDR antenna, what can you do? Like it's not about building a high sensitivity bespoke package that you can integrate as a payload. It's what can we collect and what can we do with that. So certainly over the next couple of years, that's where we'll focus the effort. And again, if the case or the sort of market demand for a dedicated solution comes up, then that's when we'll make the decision. And we can do that really, really close to the point where we actually deliver it, because we have this ability to take what we've already built and augment that into these new sort of solutions for whatever the market demands.
Thank you. You'll be capturing meteorites and asteroids next.
Yes, hopefully deliberately.
Yes, well, I don't know. You could be a good shield for us. There'll be enough of you up, or enough things up there to do it for us.
Yes.
Right. Well, this is another one from me. Right. On your September launch of Iron Origin, you said you had a propulsion system on board, but didn't use it as it was for validation purposes only. But did you actually get to test it or validate it later in the orbit?
So I can't answer that because I don't know. The primary mission was to deploy the planet SuperDoves, and that didn't require the propulsion system actually for the particular requirements that they had. As I say, I couldn't comment at the moment as to whether or not they've tested the propulsion system, because I simply don't know. But obviously now we have full use of the platform. We're running through a whole load of experiments and tests and looking at characterizing the full performance of this, now that we don't have the risk of customer payloads also being on board at the same time.
So will your December launch be using the propulsion system, do you know?
Yes, no, absolutely. Again, I don't think any of our customers require it particularly, but the solution is on board, so we have it as an option.
Okay, right. Progress is being made. Right, here's another one, and this is from Guillem Douari, if I can pronounce it correctly. I hope I've got that one right. Someone can write a comment and tell me whether I've got that one right. Do you work closely with the other deorbit subsidiaries in Italy, Portugal, or the US? And do you share projects or work in separate projects?
Yes, absolutely, every day. So I've talked to the Italian and the Portuguese teams today on the various activities that we're doing, and I sort of talk to them pretty much every day. In fact, as do our technical team as well. Deorbit's a really interesting business because we're essentially a completely flat structure, and we're running a bit low on time, so I won't go into the complete sort of details of what that means. But it does cross the national and international boundaries as well. So we work as a completely integrated group in that sense. My role as a program manager can be somewhat tricky because we have things like geo-return and requirements on how money is spent depending on who's paying for it, like the UK Space Agency, for example, in that previous discussion. But again, that doesn't preclude us from consulting with our counterparts in Italy as well, and Portugal, as we work through the project delivery for other areas. So it's a really cool place to work in that respect. We have this very, very integrated sort of team spirit.
Well, we've actually got quite a bit of time. Elizabeth says she can probably extend us if necessary. So let's answer them in full. We've only got 4 more questions here. So if there are any more to come in, let me know. And I think Guillem has said I've got it more or less right. So I'm pleased with that. You set out this one. I'm just trying to see who sent this one in. Oh, Alex Wood. He's here. Right. Alex says, you set out a vision including relocation, life extension, assembly, and manufacture. Do you have timelines in mind for each of those steps?
I mean, personally, no. and there may be some more senior management strategy that does put dates to them. But again, from a personal perspective, I would be uncomfortable with us trying to do any of that before the market can sustain it. So, again, it's hard to put timescales on them sort of outside of the 5 or 10-year bracket, simply because we can't get better resolution of that. As I said at the very start of this talk, if you told me 5 years ago the extent to which small satellites and CubeSats were used in the commercial space sector, I would have struggled to believe it. Starlink, we talk about it today as though it's sort of this obvious thing, but again, roll back just 5 years, it would seem incredible just then. So, it's very difficult to put these timescales on, and in many ways, it's meaningless. The point is that is the direction of travel, and we're getting to this point where we will have this space economy, as I've talked about in the in space economy, as I talked about in the presentation, where we have these completely transactional activities. These transactional activities that happen completely on orbit, and to the extent where there may not even be a human in the loop, and that's a really interesting sort of place to be, and it's absolutely where the vision of our company is trying to take us. We want to be part of that story, a major part of that story. But we couldn't tell you today who's going to be our first customer or our 10th customer, and until we know those kinds of things, then it's very difficult to put those timescales in place. What I can say, though, is that, to reiterate, everything we do is trying to push us in that direction. So, we talk about the propulsion system. It's a fundamental element of everything that we'll need to do all of those things in the future. We're working on that today, and by doing that, we will be able to continue to develop and evolve it over the coming years, to the point where it's not a problem that needs solving. When we're doing these more advanced mission concepts and activities in the future.
I know I'm going to have to come to you for advice on AI now. Right, this is another one from Alex. He's slipping them all in at the tail end here. Are there any competitors who offer or plan to offer the same or similar wide range of services as deorbit?
I mean, again, we talked about the sort of competitive environment earlier, right? Yes, I mean, you could go look across the industry and find lots of people that are doing similar things to what we're doing. But again, our strategy isn't to try and beat everybody. It's to try and find ways in which we can add value to existing services, existing offerings on the market. And back to the sort of what's our preferred solution for deorbiting, servicing solution or robotics. I don't know, but there's lots of people doing really interesting things, and we will work with them as partners to find out, what the best solution is, and that will put us in a much stronger position than trying to own a market that doesn't even exist or have definition at the moment. And again, there's a long discussion around how we build markets in this respect, and the space industry in particular, and certainly this sort of more longer term view of what services we think we'll need in space in the future means we do need to take a very open approach to it. And I have this line in my profile on LinkedIn about liking open innovation, and that's not a throwaway thing. I genuinely enjoy and think it's very critical, particularly in the space sector, where we have so many niche areas of expertise, that we do always work together in a collaborative sense, and we find ways in which we can add value to each other's offerings. Simply because if we all try to do it alone, the market will never exist. We won't be able to create that market. It won't get enough traction, and we will all fail, leaving other people then to come in and take advantage of all that work that's been done sort of independently. So it's a whole is greater than the sum of its parts type situation with many of these next steps.
Yes, a lot to look forward to. Right, we've got another of Les Shoulders ones here. Right, he's saying it's just slipped down the list. I'll finish it off while I've started. As we've seen from the troubles OneWeb have recently been through, do you believe, with so many large constellation systems on offer, that if one were to fail financially, that the predicted number of small satellites to be built could be put back by a considerable timescale?
I mean, yes is again sort of the short answer to that. We do sort of have these 2 or 3 big players that are building the mega constellations, and they're going to present a large part of the market. There's a segmentation discussion there around what services those organizations will need, that perhaps adds a bit more sort of flavor to that. I won't go into it just yet. We could possibly come back to it. In terms of what that means for the industry, so currently with the large constellations, certainly ones that are proposed, that they're kind of cheating the market in a way. Starlink is not a commercially sustainable solution, right? It's taking Elon Musk and SpaceX money and investing that as a huge loss leader. Now, great, that's a very sort of Silicon Valley approach. You kind of chuck money at the problem until you own the market, and then hopefully you can monetize it to an extent where you recoup all that in the long run. The Blue Origin one, or whatever it's called, Kuiper one, is another interesting one, because again, it's like Blue Origin. Blue Origin is funded by Jeff Bezos and Amazon. They're not commercially viable as a business otherwise. So those are special cases, right? That give us examples of things where they probably won't fail because they do have a lot of money behind them. Equally, it's at the whim of 1 or 2 people's kind of interest of the month that might make them go away or come back. So there's a broader discussion though, which is, what about, if I remember from that plot that I put up, about 50% was the sort of large constellations, but there's another 50% of other constellations, and actually that's the really interesting part, I think. Certainly, again, with these big players, they sort of are quite vertical anyway in terms of their integration as a company. But what we do see is everybody else that's trying to create specific and niche services, a niche in the best possible way in this sense, where they want to deploy a commercial Earth observation solution for forest fire monitoring, and that's what it's done, and that's what it does. There's perhaps a small company that's got a good portfolio of customers, and they know they can close a business case around serving them. And then the satellites just become an asset, right? It's like the laptops or the machines in the factory. The space bit almost becomes slightly kind of secondary, if you like, which is hard to tell to people that love the space sector, right? It's just space. So what we will see, I think, over the next kind of 5 or 10 years are lots and lots and lots of these smaller constellations, the tens, maybe hundreds of satellites. And they will come and go. Some will flourish more than others. They're all going to need the services that we're going to provide. And probably what we'll see in sort of 10 years' time is the ones that do make it will consolidate into sort of 2 or 3 major players that might then compete with these really big ones that are funded in a fairly sort of specific way. So for the next 10 years, I think there is plenty of scope. To the competition sort of question as well, I mean, even those people that are doing very similar things to what we're doing, there's plenty to go around at this stage. Again, that comes back to that point of collaboration being much more valuable.
Right, we've got 3 more questions. We ought to try and fit them in and let everyone get off for supper. Right, the next one then is from William Easdan again. What technologies would you say are most needed for on-orbit servicing that are currently lacking?
So I think it's a good question. So there are lots of ways of answering this, and I think I guess you could break it down into sort of 2 or 3 areas. One is the kind of engineering solutions that we already have, in terms of them having flight heritage, let's say, but aren't necessarily accessible. And I'm thinking things like GNC. You can get a good GNC solution if you need it. It's actually quite hard and certainly quite expensive. So that's not necessarily a technological barrier, but there's a commercial or a logistical barrier to accessing those kinds of technologies. And until they're broadly available, I can go and buy an OBC or an EPS off the shelf, but I can't really get a good GNC solution. Some suppliers might argue that, but certainly to the kind of level of fidelity and capability you'd need for some of these more advanced services. Then you've got sort of the engineering solutions that simply don't exist at the moment, and I probably sort of classify that as things like the robotics, the sensor solutions that allow the curvature motion at close proximity in high fidelity, without dependence on a human in the loop. Again, we've got sort of examples of that perhaps, but again, it's not really a solution or a holistic solution yet. So that's sort of the stuff where we perhaps at a systems level need to understand how we put those together in solutions that are useful for this particular application. And then the third area is really, there's still quite exotic stuff. And in that, I'm thinking things like AI, machine learning, advanced image processing, high capability compute solutions, bespoke chip architectures, FPGAs. The stuff where it doesn't really have any heritage, certainly in this kind of context, and there's a lot of work that needs to be done to understand and characterize how those solutions might add value to what we're trying to achieve in this particular application. So it's not a trivial answer, because it's not really a trivial question, and as I say, there's a huge opportunity for collaboration in these areas rather than trying to sort of own all of it.
Right. Well, I think we're on to our last question now, so we can let everyone go home. Well, they're probably all still at home, to be honest. Right. The final question is from Ange and Nigel again. And Nigel asks, is there any AI involvement presently or in the future?
So I think I might have just answered this actually, but yes, I mean, certainly it would be silly to say no to that. I think, in the interest of time, I won't sort of go into too much depth about my personal views on what we call AI today. I think in a nutshell, a lot of what we call AI is actually what in the space sector we've been calling autonomy. And actually those two things are quite close in how they're applied. That being said, the amount of work that's going in terrestrially into what we're calling AI and the abilities and scale of that, I'm thinking things like the cloud services providers, can't be ignored. So I think we need to understand what AI means for the space sector and the applications that it can support. And as I said in the answer to the previous question, really characterize what benefits that brings before we sort of get too carried away by the sort of the buzz and the kind of keywords around it.
Right. Well, thank you very much, Chris. That's excellent. I think we've got through something like 25 questions or something of that number. So you've done remarkably well and in considerable detail as well. And I must thank you for coming on board for this one. It's been fascinating, and certainly looking to the future is what it's all about. Absolutely. And you've actually made some achievements as well. So, you know, imagination to reality has already happened for you in certain circumstances. I think what we're going to hope for is that we'll get you back again and see how things are going in the line. But we'll certainly thank you very much for being on board today and for answering all our questions. I must also thank Elizabeth for making it all happen and making sure that I was visible. Took me 5 attempts, but I got there in the end. And I think the system has worked quite well. I hope anyone that's got any comments will come through on our streaming email and tell us what they'd like to see next. I think also thank you all for participating in tonight's talk or the Q&A. I think it's a good way of doing it. I think we give people the chance to actually get their questions ready, because so many of us are so busy. We don't always get the chance to watch the thing just before the Q&A starts. So our next talk, we're going to experiment slightly, because we're actually going to ask Dr. Than Putzig to talk about exploring Mars with ground penetrating radar. But we're going to do it live so that he's going to actually be part of the crowdcast. He'll do his talk first of all at 7 o'clock, and that's going to be on the 16th of December. And then we'll run the Q&A immediately after that. So you'll have to be pretty swift at getting your questions in. And it'll be a slightly shorter Q&A, but I'm hoping it'll be as interesting and as exciting. And then for the future, we've actually got a load of people we're contacting at the moment to take us right through till about June of next year. And they're an international collection of people from ESA, from NASA, and from various universities as well. So that could be interesting. We've got a lot of people that we would like to get hold of to talk. And so we'll see how that goes in the next couple of months. So thank you all for a great evening. And thanks, Chris, and thanks, Elizabeth, for making it happen. Thanks a lot. Good night to all.
Thank you very much. Good night.
Okay, bye-bye. Bye.